Okay, welcome back. Today we're going to be talking about the Electrode API. So this is one of my own kind of pet projects that I worked on within this repository, and I think it's become extremely useful, especially when you want to try and do things that are pretty hard to do or impossible to do from the GUI. But obviously, since we have the power to just be able to edit the simulation environment as we go, I tried to set up an easy way for us to come up with any electrode configuration. We can come up with anything we want. I have it set to be able to do up to 100 electrodes, put in various locations, and have them all set to whatever parameters you want. But that does require you're going to be doing a lot from the command line to be able to get there. But I tried to give some nice documentation on how to do it and all the different commands you can use. And so I hope this video will kind of give you the rundown and some sample code to really see what happens here. So really this, the documentation, so if you go to the nerve block modeling repository and you go over to the wiki page, there's a little tab at the top. Then there is a thing on the side for custom electrode configuration, and that's where this page is. And then on the other side here we have the code. So there's really two files that this encapsulates. The electrode controller.hoc and the electrode object.hoc. So the electrode object, if you've done object-oriented programming before, this is the in Hoc they're called templates, but this is kind of the object or the class or whatever you want to call it for the electrode. So it's kind of at the core of every electrode. Obviously there's the model of that particular electrode, whether that's a sine electrode, or maybe it's it's square wave or a triangle wave. So at the core of that we have the actual model of the electrode, which is the .mod file, which you can find under the models folder. And so then I encapsulate that with an electrode template, and that lets me kind of interact with the electrode without actually having to worry about which type it is, because this will handle the different types and kind of figure it out for me, which is really nice. And then from there, so that's like one level of encapsulation or abstraction, and then the final level of the abstraction that we get to is the electrode controller, which then controls all of our electrode objects. So from here, we can kind of start to go through, and we're gonna first cover the key and kind of somewhat confusing data structure that overlies this entire kind of feature. So using the electrode controller procs, we can create any electrode setup, and we have electrodes. So the actual objects are stored in the electrodes array. Okay, that's good. So now, so as we build up, we can use the standard dot syntax. So we can do electrodes and then index 0 dot whatever, and we can access that particular electrode if we just do electrodes whatever index, and then we can just throw a dot, set amplitude or something. So what is this other array? And the other array is essentially how we're going to keep track of what electrodes are actually being used. So obviously we're going to be creating electrodes and adding them to the array, and then we're going to take electrodes and remove them from the array. And so instead of having to try and figure out how to move electrodes indices, not only does moving them, would that require, let's say we delete the first electrode, and then numbers 1 through 99 have to all move up 1. That's confusing. But beyond that, if you're writing some programmatical stuff, all of a sudden all of your electrodes just change what index they are if you happen to remove the 0th electrode, and that can be a big problem. And so to try and keep the consistency of when you create an electrode, it is going to stay that index for the entire life of that electrode. To keep that key functionality in there, the available electrodes is essentially just a array where at each index is a number that is like a pointer to some other index location. And it's not actually a pointer, it's really just the index of wherever you should look at. So the way to think about this is that we have kind of two singly linked lists. One of them contains all current electrodes, and the other contains all the unused electrodes. So if we look at the controller, we can see the first electrode index is -1 at the beginning, and the next electrode is at 0. And so, if I went to index 0, right now, that's kind of the start of all of the open spaces, because we have to keep track of which spots are open and which ones are not open. And so all the spots that are not open, one of them starts kind of this linked list structure that's kind of intertwined in this array. We start at index 0, and that holds the value of 1. So then we can go to index 1, and that'll also be open, and then that'll point us to index 2, and that one will also be open. And you can see how that can point through the whole array. But now think about the concept where we have indexes 1, 2, and 4 all have an electrode, and we deleted 3 for some reason. That means index 1 will be our first electrode index, which will tell us to look at 2, which can tell us to look at 4. And then 4, that one will give us a value of -1 to show that's the end of our list of electrodes. And then if we started at index 3, we would be able to see that that one points to all the extra empty spots. And we can use the empty spots to then kind of link it. So it's really two linked lists stored within one electrode array, one available electrodes, which is it's just a integer array. You don't really have to worry about it that much. Most of the time you can kind of just use the output electrode and see what indexes are where. But it's kind of important to know why we need it. So let's look at some of the electrode controller procs, and then we can move to the individual electrodes. So the key ones, obviously we need to turn on and turn off custom electrodes. This also, when you turn it on, it turns off all the other setup for your environment. And when you turn off the custom electrodes, it turns on the normal GUI interface stuff. So those two kind of go hand in hand, so make sure you turn it on when you start something. To output the electrode setup, this is extremely useful when you make, once you get to 3 electrodes, it can get a little tricky, and sometimes you don't know exactly which index they are. So outputting the electrode setup allows you to just output all the different electrodes that you have, what parameters they currently have, so that you can see, okay, yeah, everything is exactly how I want. The save electrode config is extremely useful. When you are finished running something, and let's say you save some data from a particular run with a particular electrode setup, if you save the electrode config, it will save all the commands required to recreate that electrode configuration, which essentially means you can save exactly what your setup was. And then you can just move that file over with your data, and that way you know exactly what the setup was when you're looking at your data, because they're all in one location. Very useful. And then the last ones are kind of where we finally get into the electrodes. So we can create an electrode, and we set a type and a position. You cannot change the type, but we can eventually change the position. So we create an electrode, it assigns it some index within our electrodes array, and based on these types, so the type is an int, it's either 0, 1, 2, 3, or 5. 4 I think is currently under work, and the sign ramp, a lot of the functionality doesn't particularly work with it, just because the sine ramp is such a unique unique electrode. So if you do use that, you're going to have to go a little bit deeper as you're working with it and have a bit more nuanced knowledge on the sine ramp mod and all the functionality when you go directly all the way to the electrode model. The other things, the X and Y pause, the position of the electrode are relative to the center of the axon, and the units are microns. So the location of XY of 0, 1000 will be 1 millimeter above the dead center of the axon. So you have the axon, you know, across the screen, dead center is 0, and then it goes to whatever, like minus 6000 or positive 6000 or whatever it is. And then the Y position will just, it doesn't particularly matter, but up is positive and down is negative. So so that's creating an electrode. Then we can remove the electrode just by knowing its index. And when you remove it, you can use the output electrode to check and see which index you've removed, and it won't change the index of any of the other electrodes. From there, we can set the extracellular voltages. It does that for the entire axon, given a current electrode setup, and that's useful for when we're taking timestamps, or when we're taking individual time steps, and we need to set the extracellular voltage at every time step. So that's what should be called. Then from there we have the set amplitude electrodes, and this is a useful function because it ties in with the block threshold finder. So you set up a custom electrode configuration using this method or this procedure, or proc. The block threshold finder can actually set the amplitude of all of your custom electrodes as well, which means you set up a couple electrodes. Let's say you want to try 5 sinusoidal electrodes, and you wanted to try and see what the block threshold is for that. You can still do that because the block threshold finder uses this, and it'll set the amplitude for all electrodes you are using to the same amplitude. So that means even if you're using a couple, let's say you're using sine waves and some square waves together, even if you're doing that, they're going to both be set to the same amplitude. So just be aware of that. So then this gets us into the electrode template. So all of these functions here are in this, in the electrode controller file. And so that's pretty much everything here. So let's go over to the electrode object. So this is the kind of class file or template of that encapsulates our electrode model. So first off, what are the things we have? So the electrode model. So for instance, this is kind of that dot syntax that I mentioned before. So we can do electrodes, and then in square braces we do the index, so that accesses the particular electrode object. Within that we have the electrode model, and the electrode model will literally let you go directly to the model that is associated with this electrode. So you have a sine electrode, within this electrodes object. When you do the dot electrode model, you can go directly to the model and change parameters if you know how to do that based on the model file. Otherwise, if you don't, you change this electrode model to something like set pause. So you do electrodes index dot set pause, and then whatever parameters you want to pass it. So that's kind of the dot syntax, and it'll make sense when we do a little demo. So we have the electrode model is one of the things you can access. We have the calc voltage. This will calculate the voltage at a particular X and Y coordinate, and it calculates kind of from there we can calculate the compartment voltage. And this is key because we're doing this ahead of time, so that we're storing the extracellular voltages across the axon. We're going to do that and save it before we start running, because if we have to calculate this long calculation here at every time step, that's going to slow us down a ton. Whereas now that we've saved it, when we actually calculate the compartment voltage, we can do just one simple multiplication of the model's amplitude times some ratio that's going to decrease by, based on the resistivity and distance from the electrode. So that calculates the compartment voltage. So these two you really never actually have to do yourself. Most of the time they're just going to be done ahead of time when you do various other things. So that gets us into the actual things about the model that you would want to do. You can set the position and move the position. This does the calculation ahead of time to speed up calc voltage. Okay, so you can optionally, it can be passed two arguments, x and y, which changes the positions to those exact x and y values. Again, that's like what we did before. When you create the electrodes, where the center of the axon is 0 and everything's in microns. The move position is a similar thing. If for some reason, instead of setting the exact position, you just want to shift it over a little bit, maybe you're kind of running a bunch of tests where you're just moving it one after the other, this can be useful. Then we have the set amplitude. So these are a lot of setters and getters if you're used to that kind of terminology. So we're going to set the amplitude, and then whatever amplitude you want to set, and it's in nanoamps. And we can set the frequency. Now this is obviously not important for the DC electrode, but for the other electrodes it's useful. We can set the duration for how long the electrode will be on. We can set the delay for how long we wait till we turn it on. You can set the opposite polarity, which is useful for, let's say you have two sign electrodes and you want to try them in a bipolar configuration. So when one is cathodic, the other is anodic, and vice versa. So that's useful. And when you set amplitudes, it'll make sure it sets the reverse amplitude. If it doesn't set the reverse amplitude, it'll still function as the reverse amplitude. So from there we have all the getters, which are self-explanatory. Get the amplitude, get the frequency, get the duration, get the delay, x and y positions, the model number. So let's say you kind of forgot what the model number was, you can get it. The print data prints out that particular electrode, some key things about it. Usually you don't have to do that because you're going to output the electrode setup, and outputting the electrode setup kind of does all of it, and then you don't have to worry about particular ones but you can if you need to. And the print data advanced also kind of gives you a bit more about it. So okay, that was a lot of that's a lot of documentation and a lot of commands. How do I actually use it? So let's open up the Neuron GUI, and we will open up, let's see, the GitHub Neuron current simulations and the models folder, which is in our recent directory, and we know it's right because it opened up all these mechanisms. And from there we can load a Hawk file, we can go up a folder level, and we can run the cnow_Hawk. Okay, we got a lot of windows here. The key ones, let's look at the voltage plot, because that's going to be our main one today. It's the space profile. And you know what? That's really the only one we need to be looking at for now. So let's do just kind of a simple exercise. We're going to try and set up 2 electrodes. So first things first, I'm actually going to move this over here so that I can see it a little better. We're going to turn on custom electrodes. Cool. And so one of the things you can see is that none of our electrodes are now checked. It unchecked the sign electrode, which was previously checked. So we know now we're in our custom electrodes, and now we have a lot more power. So why don't we first create an electrode? So we create electrode, and now we have 3 parameters we have to pass. First, we have to pass it a type. I kind of feel like doing a sine wave. And now we want to pass it an X and Y position. So normally, for this, what might be useful is first we might want to figure out what the X position is. So before typing this command, so we're kind of getting there, if we do delta X and we hit enter, it'll give us a value. And this particular value is the distance between nodes given your current setup. So if I change what diameter of the model I'm using, it's going to change what this delta X value is. So that's going to be really useful, because now I can use this for calculating what X position I want to use. So I want to set one electrode that's going to be 2 nodes away from the center. So if I create electrode, and we're going to make it a 0 type, which is a sine wave. From there, we can set the X position, which will be negative 2,300 microns, or negative 2.3 millimeters, and we can make it 1 millimeter away from the axon in the Y position. So that's that electrode. Let's create another electrode, and this one we're going to put it as a positive 2,300 and 1,000 position. So this will be 2 nodes on the other side of center, but still at 1 micron away. And then the key here, output electrode setup, and we can look at what we have. Okay, so it's going to spit out a lot, and we're going to walk through it. So first we have our index, which is 1. So this is the index 1. So if we were looking at our electrodes array, that would be how we access it, with electrode square bracket 1 and square bracket. So we can see the X position and Y position being 2,300 and 1,000, which is what we want. Okay, the amplitude, it looks like, is 1 million nanoamps, which is 1 milliamp. The frequency is 10 kilohertz, and the duration is 300 milliseconds, and the delay is 0 milliseconds. Okay, so that's okay. So maybe we can adjust the delay so we can see each one fire on one side or the other. And then from there, we have the exact same thing, just with a different X position. So what happens if we hit run? Theoretically, they both come on at the same time, and we should be able to see kind of 2 peaks. So let's run it and see if we can stop it. Yep, there we go. We can clearly see that our 2 peaks, and if this is the center node here, we are 1, 2 from center on this side, and we are 1, 2 from center on the other side. And so now we've created our 2 electrodes, and they do exactly what we want. Now let's see if we can change some of their parameters. So first, let's think about which electrode we want to change. Let's change this electrode on the left side, which would be negative 2,300, which, if we're looking, is index 0. Let's change it so that it's at a lower amplitude. So what we can do is we can do electrodes square bracket 0, because we know this is index 0 of our electrodes. And then we can do dot set amp, and then we can set the amplitude to whatever we want. So right now it's at 1 million. What happens when we cut it in? Let's go with half. So 500,000, and then set it. So now if we end it and run, we can see the electrode on our left side. We set it to half of the amplitude. of what our right side is. So now let's just kind of do some other things. What if we change the other electrode to have a bit more of a delay? So let's say it has, I don't know, maybe a 10 millisecond delay. So we go to electrodes, and now we know the other one at the positive x position is index 1, and we can set delay, and we can set it to 10 because it's in milliseconds. Okay, so now theoretically, if we run, we start with only one electrode, and then the second one will turn on after. So we have one, and then there's the second one. Cool. So there it is. And then we can stop it, and we can see they're both on. So this was kind of an overview of everything. From here, what we can do is so we can output electrode config again. And I must have typed it in wrong. Oh, it's output electrode setup, and then it caused it to crash. But regardless, from there, you could also do things like the save electrode config is pretty nice because it'll turn all the commands you previously did and save the electrode setup as a series of commands. But other than that, you should be able to figure out the rest. And obviously, once you have your electrodes set up, you can also use the threshold finder. The one thing I would give you as a note is because it's setting every electrode, when you have your electrodes set up, I would recommend turning a couple of them, set the duration of them to 0 for when you don't want to get the block threshold of those. So as an example, let's say you have, for some reason, you have a square wave and you have a sine wave, and they're on opposite sides of the center, and you want to run both of them at block threshold. I would turn one of them, so I'd turn the square wave, I'd set that to a 0 duration and run. So the 0 duration means that the square wave will never turn on, but I'm still using my nice electrode config setup. And from there, it'll find the block threshold of the sine wave, and then you set the sine wave's duration to 0, and then you set the square wave back to whatever duration you want, and recalculate the block threshold, and now you'll have the block threshold of both the square wave alone and the sine wave alone, and you can use that together to find whatever it is you're looking at. So that's just a helpful pointer. Just remember that outputting the electrode setup is kind of your key for keeping track of what all is going on. So don't be afraid to use it as you keep going through to make sure each parameter that you change is being changed the way you think it is. So hope this was helpful, and I'll see you guys in the next video.